a beautiful location.
This land is one of extremes.
The highest speeds we've ever had out here are in the 140-mile-an-hour plus range.
When it comes to the wind,
We get the really high wind events from the west during the October through May period, and then we get the really slower, more lazy, if you want to call it that, winds that occur in the Great Plains, but are very steady normally.
the gentle breezes that roll in from the east and the strong gusts that sweep through El Dorado Canyon make this site just south of Boulder, Colorado, ideal for research.
2 over here, 2 here.
Engineers with the National Renewable Energy Laboratory, NREL,
My name is Jim Johnson.
work in the shadows of these often massive machines.
This is about an 80-foot tall tower.
They believe the answer to many of our country's energy and environmental concerns is literally blowing in the wind.
Right now, wind is in high demand.
The goal is to really make wind-generated electricity kind of the cheapest form of energy on the planet.
Robert Thresher leads NREL's National Wind Technology Center about 20 miles north of NREL's main campus. He says wind power makes up less than 1% of the electricity in the United States. His team is working with wind turbine developers to change that.
The wind could supply up to 20% of the nation's electrical needs.
It'll take machines that perform better, last longer, and cost less.
20 years ago, wind-generated electricity cost about 40 cents a kilowatt hour, whereas today it costs from about 5 to 8 cents a kilowatt hour, depending on the site you're at.
The goal is about 3 cents a kilowatt hour. The National Renewable Energy Laboratory is rising to the challenge, designing and testing wind turbines of all sizes.
I happen to think they're beautiful.
Engineers evaluate everything from the smaller residential wind machines to utility-scale turbines that truly tower over the land.
Diameters that are large enough to fly a 747 through with 40 feet of extra space on either side of the diameter.
To make sure they stand the test of time.
It has to operate pretty flawlessly for about 20 years.
It doesn't take decades to assess the reliability of these machines. Here, the lifespan of a turbine is tested in months.
This is what we call the industrial user facility. It's designed to be able to do wind turbine blade testing.
Engineers bend the blades.
The tip is nearly touching the floor and almost touching the ceiling when it's deflecting.
Even break them both inside and sometimes partially outside this building.
You're only seeing about the first 30 meters of it because the other 15 or 20 meters is outside the building.
It is spectacular to see.
We're one of maybe 4 or 5 labs in the world that can do this, the only one in the United States. It was designed to be able to accommodate 2, maybe 3 different manufacturers at the same time and keep their information and hardware segregated.
This is the control room for the dynamometer test facilities.
The wind turbine drivetrains are put through equally rigorous trials.
So the drivetrain consists of this main shaft, the gearbox, the generator, and then the system that converts that electricity back onto the grid.
So we're simulating the wind mechanically.
Industry partners use the information to iron out problems with their prototypes. The innovations of the future are generated here. The next frontier takes the wind turbines into the water. It's already a reality in Europe.
When we look at the potential for offshore, it's enormous.
28 states border a coastline.
Inside those 28 states, we use 78% of the electricity in the nation.
All of the wind sites in the U.S. are on land, and moving electricity isn't easy when the system is more than a century old.
It doesn't do a good job of being able to take that resource in the center part of the country and move the electricity to where the loads are. That's our biggest obstacle in wind energy in the United States right now.
Water isn't the only uncharted territory.
To reduce the cost for land-based systems, to go into lower and lower wind speed regions.
NREL is developing turbines to create electricity where the wind just isn't as strong.
There's 20 times more lower wind speed sites throughout the Great Plains than there are the higher wind speed sites.
Expectations are high. The turbine towers are taller than ever to tap into the rich winds at greater altitudes.
Every time I try to guess where the maximum size of a machine will be, I'm always wrong. It keeps growing and growing.
The machines are more powerful, they produce more energy. That means fewer, for example, on the land of a rancher or farmer helping to harvest the wind.
He gets a $200,000 a year income from those 100+ machines on his property.
Cultivating low-cost renewable energy.
Then you can be a good citizen and be green and clean.
NREL's National Wind Technology Center is pioneering the field to harness the power of nature.
It's really a great challenge. It's been a great challenge, and it's a great joy to see it going out and being used.